Welcome to AB Video 2.2e Part 2, more on rate of change.
Okay, so again, coming back to the whole idea of dy dx is the rate of change. When you see those three words, rate of change, you got to think derivative. Instant. Now notice there's no word here, so it's automatically implied this is the instant rate of change. If it's average rate of change, then you should be thinking just slope between 2 points. But the rate of change is the derivative. Whichever word comes after the word of will be in the numerator. Whatever word comes after the words with respect to will be your denominator. Okay? So this is like number 107. It says the volume of a cube with sides of length s is given by, as if you don't know the formula for the volume of a cube. The question is this: find the rate of change of the volume with respect to the s, which is the side length, when s is 4 centimeters. So they're asking you to find the derivative of v with respect to s when s is 4 centimeters. So that's what they're asking you to find. Okay? To find dv ds, before we can find the derivative with respect to s of the volume, we need the equation that relates the volume and the edge length, which of course they gave us, is v equals s cubed. Now, notice how this is dds of v. I'm taking the derivative with respect to s of v. What I'm going to do is do that to both sides. On the left, I have dds of v, which is dv ds. On the right, I have dds of s cubed, which is the derivative with respect to s, which is this variable, of s cubed, which will be 3s squared. And therefore, the derivative, or the rate of change of the volume with respect to the edge length at s equals 4, I'll replace the s by 4, and I'll get 48. Now, be very careful. This is 48 cubic centimeters because it's the rate of change of the volume with respect to s, which is the edge length, which is just in centimeters. You do not cancel out the centimeters with the centimeters cubed and give me an answer of 48 centimeters squared. First of all, that is not a rate, because a rate has to be a fraction, okay? And secondly, this looks like an area. We're not talking about an area. What this really means is that the volume is increasing, because our answer is positive, at the rate of 48 cubic centimeters for each increase of 1 centimeter in the edge length at that moment. At another moment, it might be a different number altogether. But at that moment, as you move from 4 centimeters to 5 centimeters in your edge length, the change in your volume is a change of increasing by 48 centimeters cubed. Okay, so do not cancel those, and make sure you have those units of measure. Okay, now we're talking about differentiability in exercises 117 and 118. Find A and B such that f is differentiable everywhere. This will be on your next test. This will be on the AP. Okay, so let's say you had this example right here. They say find the values of A and B such that f is differentiable at x equals 2. Now, it could just as well say everywhere, because both of these are polynomial functions, so the only possible place it would not be differentiable would be at 2. Now remember, in order to be differentiable at 2, it means that f prime of 2 has to exist, which means the derivative from the left of 2 has to equal the derivative from the right of 2, which is very similar to a two-sided limit, because that's what derivatives are. They are limits. So the first thing I'm going to do is I'm going to find the derivative piece function. Now remember, a and b are constants. So if this was 3x plus 5, the derivative would be 3. So the derivative of ax plus b is a, if x is less than 2. The derivative of 2x squared minus 1 is 4x. Now the key thing that you'll notice is this says greater than or equal to 2, this says greater than 2. I cannot put that equals there. That's exactly what I'm trying to figure out. Can I put the equals there? So for f prime of 2 to exist, which means for f to be differentiable at x equals 2, we need the derivative from the left of 2 to equal the derivative from the right. Well, from the left of 2, the derivative at 2 is just a, because you're going to replace x by 2, but there is no x to replace. The derivative from the right at 2 will be 4 times 2, so you find out that a is 8. Now, at this point, you might go, Okay, so how do I find b? Well, this comes back to a very important fact that we learned, which is if a function is differentiable somewhere, it has got to be continuous there. So you would go back to the original function, and of course, here's our trilogy for continuity at x equals 2. That was our original function f of x. F of 2, you use the bottom piece, you'll get 7. The limit as x approaches 2 from the left piece, you'll replace the x by 2. And don't forget, it is a times 2, but we do know that a is 8. And the limit as x approaches 2 from the right, again, you plug 2 into the bottom. So you end up with 16 plus b equals 7, b equals negative 9. And of course, once again, that 8 that I got here is from here. Okay? Okay, one more thing from here. Again, remember the difference between an average rate of change and a rate of change or instantaneous rate of change. Average rate of change, they'll give you 2x values or 2t values, and it'll say from and to, whereas an instantaneous, or it'll say on an interval. Instantaneous rate of change or just rate of change will be at a particular number. So instantaneous rate of change is the derivative at that number. Average rate of change is just the slope between the 2 points, where these are the x-coordinates of the 2 points, and the y-coordinates you'll find by plugging them in. So we know that already. I want to bring that to the next level. So what happens is the velocity, which is the instantaneous velocity at t, given that the position function is s as t, is v equals ds dt. It's the derivative. But if they ask you for the average velocity from t1 to t2, then that's going to be the position at t2 minus the position at t1, like the height at t2 minus the height at t1 over t2 minus t1. So that'll be just a regular old slope formula. So again, the velocity is ds dt, which is derivative. The average velocity is y2 minus y1 over x2 minus x1, which is not a derivative.
And that's the end of video 2.2e, part 2.